Section 1.7, example 52, find an antiderivative involving the inverse tangent function. So find the antiderivative of this function. All right, so they're changing it up on us. This time they're using the plus. And let's see. So whenever we look at a triangle like this, the only time they're going to use the plus is when we have a value right out here. So let us see what we have. So our triangle, let this equal y. And it looks like have this out here, 1 plus 4x squared. So let's see, we could have either or. So this could be 1, this could be our 2x. So 2x or 1. So opposite over adjacent, opposite over adjacent. Looks like it would make more sense to have it the opposite way. So instead of 1, 2x, we'll say 2x and 1. That way we can use tangent. So tangent of 2x over 1 seems like numbers that are a little bit easier to work with. So we're going to let tangent of y equal 2x over 1, or we could just simply say 2x. All right. So that means that we have 1/2 tangent y equal to x. All right. I'm liking it so far. All right, so taking the derivative of both sides. So the derivative of tangent is our secant squared. Secant squared y dy. The derivative of 2x is just going to be 2 dx. Or you could think of it as 1 over 2 and simply dx on that side. So let's start integrating, see what we end up with. So integrating here, everywhere we see an x, we're going to plug in 1/2 tangent y. So 1 plus 4 times 1/2 tangent y squared. And here we have 1 over 2 secant squared y, and dy I'll put over here on the side. So let's simplify this. So 1 over 2, we could grab this, bring it out to the front, coefficient. And the numerator, we have secant squared y over, here we have 1 plus 4, 1 over 4 tangent squared y. This is dy. Ooh, those 4's divide out. 1 over 2 integral 1 plus tangent squared y secant squared y dy. It looks pretty good here because I know that this is actually equal to secant squared. So 1 over 2 integral of secant squared y over secant squared y dy. So we're just integrating 1 over 2 dy. It's 1 over 2 y plus c. But we're not in terms of y, we should be in terms of x's. So the other equivalents that we have here, I'll bring it up here. So we have y is equal to tangent inverse of of 2x. So y is equal to tangent inverse of 2x, so 1 over 2. Tangent inverse of 2x and plus c. And there we go. That is our function. And that's it there. Oh, here we go. So if you have any questions, please feel free to ask. Otherwise, bye.